Good day, students. Welcome to part two of finding the composition of functions. This is a continuation of the part one. I'll advise you to go over part one, the part one clip if you haven't already seen it. There I go over the formula and how to apply it. Okay, so in this clip I'm going to be going over an example using the formula of composition of functions that I went over in the previous installment. All right, so let's write down the instructions for this video first, and then we'll go ahead and try the example. All right, so example example two. Um, for for the given functions, find f composed with g of x and g composed with f of x. All right, and then the functions are f of x is 2x squared, f of x equals 2x squared plus 3x, and g of x is 2x minus 2. Alright? Alright, let's go ahead and do it. So we're going to start, let's do A part. We're going to find f composed with g of x first, okay? So what does f composed with g of x? What on earth does this mean? Well, it basically means that we are inputting this function into that function, alright? Remember, the first function is always the parent function, and the second function is the input function. So what we're going to be doing is we're going to be inputting g into all the x's in f, alright? So what the formula is that we went over in the previous example tells us is that f composed with g of x is basically f of g of x. Okay, you can see how g has been inputted into the x of f of x, alright? So let's go ahead and do this. So to execute this algorithm, what I'll do first is I'll identify my parent function, which is the first one in this part. Okay, so the parent function is f of x is 2x squared plus 3x. Now I'm going to compose it with g. So before I do the composition, I'm going to clear out the variables. All right. So on the left side, I'm going to clear out the variable. I'm going to put in the name of the input function, and on the right side, I'm going to put in the value of the input function, which is a binomial of degree 1. So let's make the parentheses big enough to accommodate this binomial right here. So 2 parentheses square plus 3 parentheses square. Okay, so it's good to clear out the x's first so you make room for the input function name and the value, right? So the name of the input function is g of x, because that's what comes second, g of x. And what is the value of g of x? The value of g of x, the problem tells us, is 2x minus 2. So we have 2x minus 2 and 2x minus 2 here. Okay. Alright, so here we're just going to simply use the properties of algebra to just simplify the right side of this equation. Alright, so here we're going to have 2. Since we're squaring it, that basically means we're multiplying 2x minus 2 by itself. And then this right here, just simply distribute the 3 to both of these quantities in the parentheses, these two terms. So we have 6x minus 6. Now let's expand this by FOILing or distributing. So 2x times 2x is 4x squared. 2x times 2 is negative 4x. Negative 2 times 2x is negative 4x. And then the last, negative 2 times negative 2 is positive 4 plus 6x minus 6. Alright? Now let's simplify this first before I distribute the 2. Alright? So we have 2 4x squared stands alone. These two terms are like terms, right? So we can combine them. Signs are the same. You add and keep the sign. Negative 8x plus 4 plus 6x minus 6. Alright, now distribute 2 to everything. So we're going to have 8x squared minus 16x plus 8. Okay? And then plus 6x minus 6. Alright, so let's combine like terms. 8x squared stands alone. And then we can combine negative 16x and positive 6x to give you negative 10x. And then 8 and negative 6 to give you positive 2. and that is f of g of x, like that. All right. Okay. Let's move on to uh, question number question number two. Question two, I mean the B part. Sorry, the B part we're going to find the reverse composition G composed with f of x. All right, and what on earth is this? This basically means this is the parent now, and this is the input function. So this will get inputted into that, and the formula tells us that G composed with f of x is basically G parentheses f of x, like that. All right. So what we're going to do first is write down the parent function, because that's what comes first. The parent function is the function that comes first, and that is basically 2x minus 2. Now, I'm going to input f of x into g, right? Let me just write down what f is on the side here, so that we know where we're going. F of x equals 2x squared plus 3x. Alright, so in order to input f into g, I need to create room, right? So clear out the x's. On the left side, we're going to put in the name of the input function. And on the right side, the value. You notice it's a binomial of second degree, right? So since it's a binomial, make the parentheses big enough to accommodate that. Minus 2. Alright? Now, the name of the input function is f, so that goes on the left side. And the value is 2x squared plus 3x. So there's only one spot here because you have only one x here. So it's 2x squared plus 3x. Okay? So let's simplify it. We're just going to distribute 2 to both terms here. G of f of x is simply going to be 4x squared plus 6x minus 2. And there you have it. Okay? All right, thank you so much for paying attention to this presentation. Please subscribe just by clicking up here to subscribe to my videos so you can get future updates. If you like this video, you can click like down here. If you didn't like it, you can send me an email or make a comment, and I'll be glad to address it in subsequent videos. All right. A collection of my clips can be found at mouthgoodsurf.com, and if you want, you can feel free to request videos. All right. So thanks again, and have a wonderful day.